Okay guys, so this is just a pretty quick overview of the humoral response, one of the responses in the adaptive or specific immune system. So far we've looked at the first line of defense, the barriers to getting infected in the body. Then we've looked at the non-specific or innate immune system, so the macrophages, complement proteins, all of that stuff that indiscriminately kills any pathogens it finds. And then we've got the adaptive immune system, also called the adaptive immune system, so the specific or adaptive immune system. So there are two parts to this. There's the humoral response and the cell-mediated response. This video just focuses on the humoral response, which is the response of B lymphocytes. So involves B lymphocytes and also the proteins they produce, which are antibodies. Now, antibodies are required knowledge by VCAR. They require you to know how they look. You've got to be able to sketch them, recognize them. So there is my diagram of them. There is one in your slides as well, but you may want to pause this quickly and just sketch that down. But as you can see, they've got two heavy chains and two light chains. Towards the top of the heavy chains is the variable region, so the amino acids that make up that region will be different depending on what antibody it is. And they finally got an antigen binding site at the top of the two chains where they bind with antigens. Okay, so that's what an antibody looks like. And these are protein-based molecules. They're sometimes called immunoglobulin, which literally means immune protein. And they are usually specific to a certain antigen type. So the antigen binding sites at the top will bind with a specific antigen that belongs to a specific type of pathogen. Okay. So this part of the specific immune system, the humoral response, relies on using antibodies to fight infection. So we'll have a look at how that happens. So linking back to what we looked at last time, step one is that in a lymph node, the antigen of a pathogen binds with a specific B lymphocyte. So that antigen may just have been presented by a dendritic cell or another antigen-presenting cell, or it might be found directly on the pathogen. But either way, that gets to the lymph node, it's recognized by a B lymphocyte, and the specific B lymphocyte for that antigen and the pathogen that it came from will be essentially activated. So it undergoes a process called clonal selection when it's activated, which basically means it makes many, many copies of itself. So remember, it's only one B lymphocyte being activated, only one B lymphocyte that's specific to the pathogen, typically. But then when it's activated, it clones itself. So it makes many, many copies of itself, loads and loads of them. And then stage 3 is these clones, which we call B plasma cells, begin producing antibodies really rapidly. And by rapidly, I'm talking in the region of 2,000 per second per cell. So maybe hundreds, maybe thousands, maybe even millions of these B plasma cells, and all of them are producing 2,000 antibodies per second during a response. So next time you're ill and you feel really, really tired, that's why these cells in your body are working so hard. They're making 2,000 antibodies per second, and that's a big part of why you feel so tired when you're ill. So these antibodies are produced, and then they move through the blood to the site of infection, and then they coat that the pathogen causing infection. So when they coat it, that stops it being able to move, which makes it very easy for the macrophages and neutrophils to digest them using phagocytosis. They may also activate complement proteins, which will destroy the pathogens, or they may deactivate the toxins produced by them. But they do all sorts of things that just stop the pathogen working. But the most common one is just coating it with themselves, stopping it moving, and making it very, very easy for the macrophages to destroy. I'll link to another video showing a pathogen evading a macrophage. So that's when it hasn't been coated by antibodies. when it is coated by antibodies, it's almost impossible for the pathogen to move, which makes it very, very easy for the macrophages to destroy them. Now, finally, this is really important. During all that happening, memory B cells are also produced. So there'll be maybe a couple of dozen of these also produced, and they just remain dormant in the body. And they remain there for potentially the rest of the life of the organism, and certainly for decades and decades they remain. Okay? And basically, those are there so that if the pathogen is ever encountered again, they will very quickly undergo this process again, make plasma cells, and produce antibodies very, very quickly. The result of that is this secondary response, meaning when you're exposed to a pathogen that your body has already fought off, will be much, much faster and essentially stop you getting ill. So maybe one day you've felt a little bit of, feel yourself starting to get a sore throat, or maybe your stomach starts to feel a bit ill, but nothing happens. You don't end up getting a full-blown cold. You don't end up spewing and stuff coming out the other end as well. That may be because you've been infected by a pathogen that affected you when you were younger, but your memory B cells recognized it and very rapidly produced antibodies which fought it off before you even realized you were ill. Okay? That mechanism is really important in vaccination, which we'll look at in a couple of weeks. But yeah, that's really just the broad overview of the humoral response and how it works. So B lymphocytes get activated, they clone themselves, making B plasma cells. The B plasma cells produce billions and billions of antibodies. The antibodies move to the infection, they'll coat the pathogen and make it very easy for macrophages to get rid of it, as well as breaking down the toxins and activating complement proteins as well. And then memory cells get made to fight it if it ever comes back. Okay? So that's everything about the humoral response. And then we'll look at the cell-mediated response in the next lesson. And yeah, there aren't many of these lessons left. We are nearly at the end of video learning, for now at least. Anyway, that's all from me. Thank you.